This question is about compounds that contain fluorine. Sodium fluoride contains sodium ions and fluoride ions. Sodium ions and fluoride ions have the same electronic configuration. Explain why a fluoride ion is larger than a sodium ion. So to do this, you need to look at them in the periodic table. So fluorine is number 9, okay, which means it has 9 protons, which means if we're looking at a fluoride ion, it has 10 electrons, one more electron than proton. And if we look at sodium, which is atomic number 11, then it has 11 protons, but the sodium ion only has 10 electrons. So we can see why they have the same electron configuration, because they both have 10 electrons. But we can see that fluoride ion has 2 less protons than a sodium ion. So F- ion has fewer protons than Na+. So a weaker attraction between the nucleus, where those protons are, and the outer shell. So that outer shell is not held as tightly. The next part of the question says, explain in terms of structure and bonding why the melting point of sodium fluoride is high. And so we need to think, well, sodium fluoride, metal and a non-metal, and it told us about the ions. So it's a giant ionic lattice with strong electrostatic forces of attraction and it's important that you say attraction here, so they're not repulsive forces. Between, in the lattice, we've got these oppositely charged ions. And as a result, lots of energy is needed to overcome these strong attractions. The H2F plus ion is formed when hydrogen fluoride gains a proton, so remembering a proton is H plus, as shown in the equation. So remembering that hydrogen fluoride has got a regular shared pair between the hydrogen and the fluorine, and fluorine being in group 7 would have had 7 of its own electrons, it's sharing 1. A hydrogen ion has got no electrons, so the type of bond that forms is the type where a lone pair on fluorine is used to create the covalent bond. We call that a coordinate or a dative covalent bond. So the lone pair on fluorine is used to form a shared pair. Both electrons in the shared pair come from fluorine. Fluoroantimonic acid contains 2 ions. Draw the shape of the SbF6- ion and the shape of the H2F plus ion. Include any lone pairs that influence the shape. So let's look at SbF6- first. So if we look up Sb in the periodic table, it's in group 5, and we've got 6 fluorines attached and a -1 charge, that's 1 extra electron. If we add that up, that's 12 electrons or 6 pairs. And so we've got 6 pairs and 6 things attached. So we would have 6 bond pairs. There would be no electrons left for lone pairs. And when we have 6 bond pairs and no lone pairs, we get this octahedral shape with a bond angle of 90 degrees. Now if we look at H2F, F's in group 7, 2 hydrogens attached and a +1 charge means we've lost an electron. We add that up, that's 8 electrons or 4 pairs, but we've only got 2 hydrogens to attach, so it's 2 bond pairs and 2 lone pairs. So it's a shape that's based on tetrahedral, but it's got 2 lone pairs where it should have had bond pairs. And so we end up with this V shape, bond angle 104.5, because we've taken the 109.5 and squashed it down by 2.5 for each of those lone pairs. Hydrogen fluoride reacts with ethyne as shown in the equation. All compounds are in the gaseous state, and we've been given bond enthalpy data. So let's remember for bond enthalpy data that the enthalpy change is the sum of the bonds broken, so the enthalpies of the bonds broken, minus the sum of the bonds formed. So if we were to have a look, we've actually been given the enthalpy change here, and we're being asked to find the CF bond. So I'm just going to say, let's put the CF bond here and call it X. We don't know this value, but minus 179 equals, what bonds have we had to break? If we start with the ethyne, we've got 2 CH bonds and a C triple bond C, and then we've got 2 HFs. So that's everything that we've had to break. What have we made? We've made 1 CC, 348, and 4 412s, 4 CHs, and 2 X's. Minus 179 equals, and then we're going to type all that into our calculator. So we're going to do 2 lots of 412 and an 837 and 2 lots of 562. We're getting 2785, and then we're minusing from that a 348 and 4 lots of 412, 1996, and we're minusing 2x, because when we do minus the plus it becomes a minus. Now we're going to rearrange that to say 2x equals, and we're going to get 968. So if we divide by 2, we're going to get 484 kilojoules per mole.